All right, so you just got the "this meeting is being recorded" message, and you can go ahead and click through to accept that. All right, so welcome everyone to Map Time Davis. My name is Michelle Tobias. I am the Geospatial Data Specialist at UC Davis Data Lab. UC Davis Data Lab is the entity that hosts several research and learning clusters, of which Map Time is a part of the Spatial Sciences Research and Learning Cluster. So it kind of, basically we're Map Time, but we have another fancy name to go with it. What Map Time is a series of workshops and things we call studio sessions, which are more discussions, kind of less formal gatherings to discuss things. But basically, we are a group of folks who get together to talk about maps. So if you're new to Map Time, welcome. If I see a lot of returning names and faces on my screen, so welcome to folks who are you know, the usuals and the regulars. We're glad to have everybody here today. A couple things coming up with Map Time and the Research and Learning Cluster. Today, Sarah's going to tell us about agent-based modeling with Netlogo, which I am super excited for. Next week, I'm going to be giving a workshop on projections in R. So if you are confused about projections in general, there's going to be a really good intro to what projections are, and then we'll do some hands-on stuff with R. But if you're not an R person, you can still come, because the whole beginning of the workshop is not going to be really R related. So come and learn about projections with me next week. The week following that, Wesley Brooks, one of our data scientists at Data Lab, is going to give an introduction to spatial stats in R. So we've got two good R workshops coming up for the next 2 weeks. Following that, I'm going to have a studio session about art software for cartography. So if you, I'm going to be talking about Inkscape, but if you have Illustrator, things like that, you know, you're welcome to come and help translate that into that space. But come talk about how to refine maps and practical skills and things like that. And then the last thing we're going to do this quarter is the last thing of the whole pandemic year, school year, is lightning talk. So if you'd like to give a lightning talk, I'll post the links for that. Let me just grab these links and I'll put them in the chat for you guys. So in the first link there for the schedule for in the videos, there is a link to the lightning talks, and you can send an email to Evelyn Plus to get signed up to give a quick talk. These are like 5 to 7 minute talks about research or things you've been working on. Should be a really fun and informative day. So that's going to be on May 18th. We do need more folks to sign up for that. So please sign up to give a quick lightning talk. They're really fun. You really have to distill your what you want to say down to make it good for 5 minutes. The other link that I posted in there is a link to the announcement for Map Time Davis Council. And what that is it's a, you can think of it as like a board of directors, but really it's an application to join a group to help direct Map Time. Right now we have one staff member who is working on this. That's me. We need more people. We really need more input. You know, I've had some good help over the course of the year, but folks need to move on and we need to get some more people involved. So if you'd like to help out, go ahead and fill out the application. It should be pretty quick to fill out. And if you have questions, you can always let me know. It's not intended to be a big deal. We want, you know, short answers to all the questions. It's not like major essay format or anything like that. But I really would like to get some more folks in here, especially, you know, a diverse crowd, folks who do basically everything under the sun. Geo is so big, we need a lot of folks from a lot of different backgrounds. So if you're considering, you know, adding something to your CV, you know, in terms of service, this would be a really good thing to do. Or if you just want to get more involved, it's a great way to network. It's a great way to make new friends to join and help with Map Time Davis. So anyway, you've got the links, do your thing with that. And then I guess that's all I need to tell you about. Let me just check my notes real quick. Yeah, that's my list of things. All right, so then today's workshop is Sarah Grajdura. She is going to be talking to us about agent-based modeling with Netlogo. So Sarah, I will let you take it away. You're muted. There you go.
I was just trying to figure something out that wasn't working in what I wanted to show you guys, but hopefully I'll figure that out. Hi, I'm excited to be here today. I'll be talking about Netlogo, and I'm going to share my screen. I think that'll be good. There we go. Okay. So today we're going to be talking about just the basics of Netlogo. And my name's Sarah, and I'm a PhD candidate in civil environmental engineering, and I do stuff mostly with transportation. I also have a background in economics, so a lot of my work has to do with some econometric modeling. And it's just for an outline for this talk. We're going to talk about like what actually is Netlogo, so some advantages of using it, some of its programming basics, and then we're going to go over a simple example. And then I'm going to talk about mostly R and GIS in Netlogo, but also some, sorry, I have to turn those notifications off, but oh well. And then also some how to connect Netlogo with Python. And then I'm going to show some examples from my research in which I'm using Netlogo. And then there's two examples at the end. One is from the Netlogo website. It's about basically people moving around at a party. And then the second one is about a virus spread, which I thought would be appropriate because of COVID and everything. So just kind of starting off here, what is Netlogo? It's a programmable, this is from their website. It's a programmable modeling environment for simulation, and you can use it to simulate a ton of different things. It's used in a lot of different fields, from economics to engineering to computer science to any kind of social science. And it was created in 1999 by Uri Wilensky at Northwestern University, and it's been updated ever since. It's free and open source. And I put this information in here about StarLogo and StarLogo T because I think probably the people who know a lot more about programming than me are maybe interested in that. And it works on all the different platforms, and you can run it as a desktop, like an app, which here's the download link, or you can actually run it online as well. So if you guys want to go ahead and download it, you can. Otherwise, you can just kind of watch along and see if you are interested in downloading it later. So why would you want to use Netlogo? So it's used a lot for agent-based modeling, and that's when you want to have basically a lot of different independent agents who you want to simulate something and you want to see how they're going to be acting in your simulation, and you want to give them rules to follow, and then just simulate over and over and basically see what happens. And the agents can actually interact with the environment that's part of the model. And it's really good for modeling complex systems over time. It's highly customizable. It's free and open source. You can do 2D and 3D modeling. I have not done any of the 3D modeling. And like I said before, it's applicable to a lot of different fields. So these are just some of the basics. I'm not going to go into all the different parts that they call all the different parts in Netlogo models, but you have your agents, and those can be split up into like turtles, patches, links, and an observer. And then procedures are part of your model. And then if you want to learn more about the program, you can go look at the programming guide, and we're going to look at the code for a couple different examples anyways, so we can go over those then. So right now I'm going to show you guys a simple example. So if you have already downloaded Netlogo, you can open this too, because in Netlogo they have the, they have the models library. So I'm going to share my screen so everyone can see. Let's see. Oh, new share. I'll just share my whole desktop. So if you go into Netlogo, let's see, here it is. and you go into File, Models Library. So there's a ton of different models in here. And if you just want to get a taste of what Netlogo can do, you can just knock yourself out going through these. But right now we're just going to look at a simple one that looks at fire. So I'm going to open that up. And if anyone wants to ask any questions while I'm talking, that's fine too. Just try to, it might be easier if you just unmute yourself and talk, because I might not be able to see the chat. Okay.
Hi, Sarah. Can I ask you, can you show one more time where you found the model?
Oh yeah, for sure. So
Thank you.
yeah, so if you open, I'm just gonna close Netlogo and then I'll just show you guys what it looks like when you open it. Okay, so I'm going to applications and I'm gonna go to Netlogo. So I'm gonna open this Netlogo 6.1.1. So that's, if you guys went to that link and downloaded, this is what it was gonna look like. You're gonna have this folder with all this different stuff in here. And then this is what it looks like when it's opening.
So I'll just add on Windows, you can get to it if you click on your start menu and you can just search for Netlogo and it'll show up on your list of things. So for Windows users, that might be helpful.
Awesome, thank you for adding that in. Okay, so now that you have it open, it's basically just a blank slate. You can go to File, Models Library. And then here, this is where I was saying they have a lot of different models, and these are really, really useful because you could see how other people like wrote stuff. And then you can look at other people's code to kind of get some ideas and get ideas about what it can do. So the one that I'm going to cover right now, just because there's another part of this presentation that I want to show you guys that uses this model, so I thought it would be good for you guys to kind of play around with it at first. I'm going to show you guys this fire one. And so basically, as you can see here, it still looks blank, right? So whenever you open a new file, you have to click Setup. And then you see something here on the screen. On this this is the graphical user interface. So basically, I'm not going to explain anything. I'm just going to click go and see what happens, and then you guys will get an idea. So this is basically a fire that is burning through a forest. And here we have density, and this is going to be density of the trees. So if I want to make it more dense, you can see there's more green space representing more trees. And if I want to make it less dense, then I click Setup again, it's going to be a lot less dense. So if I make it a lot more dense, then you can see this is going to be spreading pretty quickly through here until it ends. So now if we want to go look at more about the info, so you have like interface, this is the graphical user interface here. And then here you have info, and this is going to tell you information about the different models that you're looking at. So what it is, like we just said, the project simulates the spread of fire through a forest. It shows the fire's chance of reaching the right edge of the forest depends on the density of the trees. So this just gives you a bunch of information, and these are for all the examples, they have this information, which is like really useful. And then this is the code here, which we can look at. So here we have our global variables, and then here we have breeds, and this every model has something like this that is basically a setup, and this is going to be telling it how to, when you click the setup button, which you saw me do, like what's going to basically be happening. And then this is basically saying like what happens when I click go. And I don't want to get too much into the weeds here, and that's also not the point of this presentation. I want to just kind of like spark your interest a little bit in Netlogo. So this is like the first example here. And I want to go back to this presentation now, and let's see, and talk a little bit about different extensions that there are. So this. So if you want to use, so one really cool thing I've found about Netlogo is that you can, when I first started using it, like a couple of years ago, I thought it was just kind of by itself, but you can, I've learned in the last year that you can also combine it with R and GIS and then also Python. So I want to show you guys a little bit about, I use mostly R, so how you can combine it with R. So there's this package called RNetlogo, which is right here. Here's the informational page about it. And basically what's really cool is that you guys saw how all the code and everything was in the graphical user interface in Netlogo. Well, if I want to use this package, I can actually run like models within the graphical user interface, but within R. So I'm going to show you guys a little bit. I found this tutorial online, which I feel like is really, really good. And I'm still learning how to do this because I haven't done this in my research yet. So I just want to show you guys an idea of like what this would be looking like. And it's using the same example that we were just talking about.
Netlogo. So there's a great package written by Jan Thiel. There's a great reference, this particular paper. I'm going to build on those examples, use those examples he provides, and I use them. You should install the package. Now make sure you have the RJava and the RNetlogo packages, libraries installed, and then set your working directory to be where your Netlogo jar file is. You can run Netlogo with or without the GUI, and I'm going to run it with, this example. So first of all, use your working directory to be the path that we're going to look at. If you look at that path, you can see that it's where my Netlogo is located. And then use this function in RNetlogo called NLStart to open a new window in Netlogo. So from R, we can directly open the Netlogo window. You can see there it is, it's opened. So this is being run through R now. What this library essentially does is it enables us to interface with the Java application, the Netlogo application. So I know with the model library, the model I want to run is the forest fire. This file path function, we just essentially write where it is, the subfolders, and you can see it comes out looking like that. That's exactly what it is on my computer. And I load it, and it loads up, and you can now use that model just as you would if you're not using R, you could just use it like that. But we're going to talk to the model from R, so using this function NL command. I'm just writing this text, and you can see it appears in the command center over here, and it just says hello. But you can do much more interesting things with the NL command function. So we can adjust this slider manually. We can set up Go manually, just doing it ourselves, but we can also use R to do it. So as you can see, I'm illustrating here. I'm just running the function, the model in Netlogo without doing it through R, just manually amending it. But let's say we wanted to do it from R. We're using this. This is the code in Netlogo set density 77. That's what we can write in Netlogo. By clicking it, you can see it's set it at 77, and we've set it up. And then by hitting go, it moves it just one tick forward. But we want to go further. We'll do that in a minute. But let's just say we want to do it at 88. We can run all those commands in NL command in a row, and you can see set density to density now, which is 88, setup and go does it one tick. Okay. Let's say we want to run for multiple ticks. Again, we'll set the density and we'll set up. And this time we'll, instead of doing NL command, we'll do NL do command.
Oh, and I just want to say, so when he's saying run for multiple ticks, so basically like every little like time chunk that Netlogo has, that's called like a tick. And so when I clicked go earlier, like it basically was just going through all the, it was just going, you saw it was just going through all the, basically going continuously through all the ticks. But if I wanted, I could just click like tick by tick and just see like what happens in each moment by moment. So that's kind of what he's saying there.
Say 100 goes, which means for 100 ticks go. So you'll move forward eventually 100 ticks. We can see how many ticks by saying NL report ticks, and it says 100. And if we do it again, it won't start again because we didn't do setup, but it'll just go another 100, so that gets 200. And the NL report will produce a bar object, which will say, should say 200. There we go. Now, let's reset the density to 60, reset up. And this time, what we're going to report is something else. So remember the global variables, burned trees and initial trees. This time we will do 100 ticks and we'll get the percent of trees burned by looking at burned trees divided by initial trees. This will give us a percentage of the number of trees that are burned. You can see that in the Netlogo, it's a percent burned box. If we look at the code, there's the two globals that we're interested in, initial trees, burned trees. These are updated through the model continuously to produce the percent burned. We'll follow that. So just looking through the model here, this is the setup, and we're going to get the initial trees and burned trees. So let's look at that. So it's doing 100 ticks, and it's now saved the burned. Let's see what it looks like. It's a list, 100 items, elements, and each one is the percent of trees burned at that particular tick. So the last one is 14.98%. You see on the right it says 15%. Unlist them, there they all are, we can plot them. So we've got the data from the Netlogo model into our, producing our object. We can just plot that as we would any other object, and there's the percent of trees burned over time. Okay, so we might not want to know, we might not know how many ticks we want to run, but we just want it to run to the end. So we can use this do report while function, and there's 5 arguments that we're running here. So you can see the 5 arguments listed.
Okay, so I'm just going to stop there. I just wanted to give you guys kind of an idea of like what that would look like. So I'm going to go on here. So so then you can also use the R extension within Netlogo. So basically, you guys are seeing all my YouTube suggestions. It's embarrassing. So you can also use like R commands and stuff within within Netlogo if you want to use the if you want to work within the interface of Netlogo. And here they have all the information about how to do that right here. And all this information, if you go to the Netlogo website, it's all on the side over here. So if I go to web, I believe, here is where you can find like all the information for like extensions, and then all the tutorials if you want to do tutorials. And there's also like more examples on here as well. So here, like here's information about what I was just talking about, the R extension. So I have not used this yet, but this is basically what I'm starting to do right now. So, so yeah, to be continued. And then another extension within Netlogo is GIS, and I have used this one, and I'll show you in the next few slides how I used it. But here you can see it's listed on the side here, GIS. So it's really cool because it lets you load in vector and raster data into the graphical user interface of Netlogo. So if you have like a road network or a country or pretty much any kind of spatial data, you can bring it in that way. So that I thought that was pretty cool and pretty fun to do. And then there's also a Python extension, which I don't use Python that much, but if I know a lot of people do, and you can find the information about that right here. So I'm going to go on right now to kind of show you guys a little bit how I've been incorporating this work into my own research. So I'm doing some research about wildfires and human response to wildfires, and especially during their evacuations. So this is, since I thought I wanted to share this because I know this is map time, so I figured you guys would like some maps. So this is just some information about the Camp Fire, which I collected data on, and this is a map of the extents of the Camp Fire in Butte County, California. And then here is some of the data I collected. So this is basically the type of alert that people received, and then when they were first alerted to the fire, and then if they received an official notification, then what time they ended up leaving. So this is just kind of a visualization of the people in my data set. And I wanted to incorporate this data, this empirical data, into an agent-based model of evacuation. So that's when Netlogo came in, and I was able to basically incorporate it. So this is kind of what I was trying to do. So I basically wanted to like incorporate people's initial awareness and basically the time they ended up leaving. And then I wanted to include like some rich data on that and apply it to agents in the model, and then like send them on their way to evacuate basically. So, and then I also wanted to include all this other information, which was about like fire spread, building data of the area, road connectivity, and then what I was just describing, the empirical evacuation behavioral data. So I wanted to throw all of that into this ABM, agent-based simulation. And then I wanted to get information out, like the clearance time for the whole network, how long did it take everyone to get through, the exposure count, which I believe, no, I forgot what that is. I think, I haven't calculated that exactly, but I think it's how many people were like within a certain distance of the fire. And then how many people were trapped basically, or weren't able to like reach a shelter. So that would give me like the proportion evacuated. And then I also wanted to look at trajectories of people on their evacuation route. So this is the model that my colleague Satra Borjigan, who's at actually University of Maryland, he and I basically programmed this together. I did most of the behavioral kind of data analysis, and he did most of the Netlogo stuff, and then we kind of worked together to kind of make sense of it all. But this is the example that we made basically. So, and I'm going to show you guys it in Netlogo. But this is just kind of a preview. So basically what we have, if you remember kind of what it looks like, the area here, this is like the town of Paradise, which I'm sure you guys have probably heard of. But obviously Paradise wasn't like the only area that was afflicted by the Camp Fire. There's also like the town of Magalia and Concow and like a lot of other small little towns and stuff around there. But for this, and in this map here, it mostly just focuses on Paradise. So this is like the road network from Paradise and like the immediate surrounding area. And basically what we wanted to do was start off with a bunch of evacuees like in their homes, and then kind of start the simulation with the fire spread, and then have people move accordingly on the road network. So this is just some shots of what it looks like over time. So this is, and the stars on here are basically shelters. And the cars are symbolized like people who can move in vehicles, and then the people are actually, we wanted to also include some people who weren't able to drive in cars, or they didn't own cars. So that's what's kind of cool about Netlogo too, is like you can set people's speed at different speeds, so you can kind of model like people moving at in my case, people moving at different speeds. And so like once you could see the red here is the fire, which we have like spreading, and you can see like once it starts spreading, well, you can't see here, but you can see how the agents are changing over time. And then here are just some of the plots that we made in Netlogo. So like the percentage of the burned area, and then like the percentage of people evacuated. So I'm going to show my model right now. And I was having a couple difficulties earlier, so hopefully this is going to work this time. Just going to stop sharing for a second. Okay. So as you can see, we have a lot more stuff added in than the kind of basic model I was showing you guys earlier. So I'm going to do the same thing I did before. I'm going to click Setup Map. And this actually takes a little bit of a while because there is a lot of information. But while I'm talking about it, I wanted to talk about some of the geographical data that I was able to bring into here. So the first thing that we wanted to bring in, we had a shapefile that had all the roads in the area. Then we also had a shapefile that was all the buildings of, we had a file that had like all the polygons of like all the buildings. And then I basically kind of made it to, I changed it to get like the centroids of the buildings, and then I made like connectors of between those centroids and the road network. So basically what we did is we would assign the agents randomly to different centroids, which represent different buildings, and then the connectors allow them to connect to the road network and then move along the network. And then what we're doing here is these shelters, which we represented by stars. So basically the agents use the shortest path algorithm, and we use the A-star algorithm to find out, and we constrain them to the road network for them to see like what is their shortest path to one of the shelters. And at the same time, we do have the fire spread that's moving, and in this situation, a lot of people weren't able to use a lot of the roads during the evacuation because they became impassable, and because of fire overtook the roads. So we wanted to also model that in our simulation. So what we did is, which you'll see when I run it, but when we have the fire overlapping any of the road segments, that road segment ends up becoming impassable. And then an agent who was trying to go on that road segment as part of their shortest path, they actually have to recalculate their shortest path again, excluding any roads that are basically unusable. So as you can imagine, sometimes the agents don't actually make it to their final destination because they might become trapped. And so in the model, those agents, we actually made it so they become either a frowning face, I believe, or a butterfly. And we just picked those. You can change the images and stuff, and we just kind of picked those randomly. So I'm gonna try to, this was not working earlier, but I'm hoping it's gonna work now. I'm gonna make it so there's not that many agents, just because then I think it will run faster. So I'm gonna just put like very few. And I hope this works. Okay, I'm gonna click setup again. And while I'm waiting for that to set up, I guess I can share some of the other sliders we have on here. Oh, okay. Actually, I'm gonna try clicking go and then see if it goes. I hope it works. It takes a while to set up at the beginning because the agents are basically calculating their shortest paths. So it might take a second to load. Okay, yeah, so can you see, I'm not sure if you can see this, but there's actually, the fire was spreading there. There you go, you can see it running now. So in this case, oh, you can see them moving now. So in this case, you can see like the agents who weren't able to basically make it to one of the shelters, they switched to frowning faces and butterflies. But yeah, you don't have to have that in your model. That's just what we picked to make it look easier. But the fire here, we have it. You can pick the direction of the fire, and you can also make it a lot more complicated. We just want kind of a simple fire spread model, but the actual fire, I believe, went this way, but we just have it going this way right now. But you can change the direction here, so that's one of the options. If you want to allow big jumps on the fire, so if you want to allow like it to like spread to different patches very quickly, you could do that. So that would actually make it more dangerous. And then here we have, we did like some divisions within the people in the model. So we had some young people, old people in cars, but I think we changed it from this version, but this is actually just denoting like different people's velocities within who are moving. And then, or these are the number of people and these are the velocities, I'm sorry. And then here, like the behavioral information that I was talking about, we were able, like here, if we want people to have a delay and when they start moving and everything, we can do that. And then I'm not going to go into all the way that we incorporated the behavioral information because it's kind of beyond the scope of this presentation. But we were able to basically create equations for different, we basically have a bunch of independent variables like age and race and sex and all these other things that are from our empirical data, and we were able to randomly assign those to the agents. And then we have equations that we got from like regression models that basically tell the agents like when to move and everything, and tell them like when to like when they will start evacuating. So that all of this information is relating to that. So then if we want to look at like the code here, again, I'm not going to go like super into it, but you can see here we have the data that I was talking about, the geographical data. I don't know if this is really small. I'm sorry if it is. There we go. The roads data set. And then we also have water, and then buildings, and then the centroids and stuff like that. So this is kind of, yeah. Oh yeah, so this is what I wanted to show you guys. So this is like what it looks like, the code for loading in like all the GIS information, the shape files. And okay, and then I'm gonna show you guys some of like the results that we got. And like I said earlier, the results were not, I did not use the R package to run the code within R, or the R extension. So this information we kind of just we exported as text files, and then I brought those into R. But this is just some of the information that we were able to get. So here we looked at travel time. So we were able to get travel time out of the Netlogo model. And what's kind of cool in Netlogo, you can set like the time that you want each tick in Netlogo to equal. So we had it to be like, I believe like one tick was equal to 1 minute. So we were able to calculate travel time in that way. So then here we have stuff like travel time, and then also departure time. So, and then we have all these different cases. So this base case here is like what we know happened from our empirical data. And then here is just from all the different simulations that we run, and we can compare all these to our base case. So, and basically what we did is we changed all those little sliders that I was showing you guys. We can change those and then see like what happens in these different simulations. So in this one, we had different delays in awareness time when people were finding out about the fire, and then you can see what happens in the simulation when people end up finding out about it later. So here you can see if there's a 30-minute delay, it looks pretty much like the base case, but you can see as the delay gets longer and longer, up to 2 hours, like this peak kind of moves rightward to the right, which means like the average travel time is increasing. And then you can see here too, there's like, as you have more delays in awareness, the travel time, there's also more variability in people's travel times. And then here we also looked at people who are trapped in like the urban fabric of the network. And that's showing basically those agents who I showed you guys, like the butterflies and the frowning faces, how those are changing over time. And surprisingly, in this case, they didn't really change that much over time. And then here, we also looked at different agents' velocities within the model. So we looked at those taking cars and those who are walking, and basically what was going to be like the differential between the two under these different cases. You can see like the gaps in the base case, they're not that different, but you can see as more delays, the difference does get a lot bigger. And then some other, I'm not going to go through all this because this is, again, I probably beyond the scope of this lecture, which is just about Netlogo. But we also looked at like different levels of vehicle access, and we were able to change that like in Netlogo and say, okay, well, what if nobody had cars? What would happen in this evacuation? Or what if everyone had a car? So we're able to look at that and then look at stuff like the travel time and the amount of people trapped in the network and stuff like that as well. And then another one we did was smartphone use. So like I was saying, we randomly assign those independent variables to the agents in the model, the evacuees, and we were able to see if we give everyone a smartphone, which is something that that we found in our data to actually really help people to depart earlier, what would happen in this evacuation. So. And then we did kind of combination scenarios. So it was really easy in Netlogo to kind of make these kind of complicated scenarios where like, basically like a lot of people were having, like, I think one of the benefits, and I'd like to go back here because I feel like that's easier to show. One of the benefits I feel like of Netlogo is that like you can have, you can complicate a lot of scenarios, but then you can do it relatively easily. So in these scenarios that we did, we had people with like different varying levels of smartphone use, different delays, and then we also had, I forgot, if different proportions of the population received evacuation notices. And that was like, it was really easy to do in Netlogo. You can basically just change these bars to kind of change your population, which was really cool. So yeah, I'm gonna go. So now I feel like I've been like kind of talking a lot. Sorry about that. I do want you guys to go and like try this on your own if you want, or we could do it together. But what I thought would be cool is if we went over like a bit of a tutorial. So if you go back, so this is the example that's on their website, which I feel like it probably explains stuff a lot better than I can. But this is the party example I was telling you about. So if you go into Netlogo and you go back to the models library, so you go to file models library, you can find this example, which is in the social science folder. And then, it's called party. Oh, and one thing I've noticed with the just a heads up, if you end up using Netlogo in the desktop, one thing I don't really like is that you can't, or maybe you can, but I haven't learned how to have like multiple models open at the same time. It seems like they just kind of closes you out if you can only have one open, which I find slightly annoying. So if you guys want to follow along, we could do this together, or like, I don't know, you guys, I could give you like 10 minutes or so and you could do it on your own. Michelle, like what do people usually do in that situation?
I think it'd be nice if you can show us, because if folks weren't able to download it, then they can watch. If that's not too much trouble for you, I think it'd be nice to see you. Plus, then we can ask you questions.
Okay, cool. So I'm just gonna follow this here. Oh, I think I saw some things in the chat. Okay, yeah, together. Cool. Okay, so like I was saying before, whenever you open a new model, you have to click setup. So if you want to say like, okay, I want to have, if you want to change any of the stuff on the bars, you always have to click setup again. So if I want to have like, right now this is at 70. And if I want to make it, make this bigger. Make this bigger. So if I wanted to make this like 170, I'd have to click setup again for that to take place. And I'm gonna follow along over here. So here in the view of this model, you'll see pink and blue groups with numbers. Do all the groups have the same number of people? No. Do all the groups have the same number of each sex? Oh, I forgot that. Blue represents men, and I guess pink is representing women. Let's say you have a party and you invite 150 people. You are wondering, how will people gather together? Suppose 10 groups form at the party. How do you think they will group? Instead of asking 150 of your closest friends to gather and randomly group, because everyone does that, let's have the computer simulate the situation for us. So what to do? Press the go button. Okay, so I'm going to change this down back to 150 so we can follow the model correctly. On the example, it won't let me. It's annoying. I'm trying to get 150 exactly. Okay, so I'm going to click setup again, and then I'm going to click right. So it says press the go button. Okay, so now I'm going to click go. So as you can see, so I said I wanted to have 19 groups of people. Why is this saying? Okay, I'm just going to keep reading through this because I feel like maybe. Okay, I'm just confused because this one looks different than ours. But I think that's maybe because I have 19 groups of people. Oh yeah, okay. So what I basically did is I'm just trying to follow the example here. And basically right now the people are sorting into different groups. And so it's saying, originally you may have thought 150 people splitting into 10 groups would result in about 15 people in each group. From the model, we see that people did not divide up evenly into the 10 groups. Instead, some groups became very small and others became very large. Also, over time, the party changed from all mixed groups of men and women to all single sex groups. What could explain this? There's a lot of possible answers. The designer of the simulation thought that groups of parties don't just form randomly. The groups are determined by how the individuals at the party behave. The designer chose to focus on a particular variable called tolerance. And that's what you can see here in the slider bar. Tolerance is defined here as the percentage of people of the opposite sex an individual is comfortable with. If the individual is in a group that has a higher percentage of people of the opposite sex than their tolerance shows, then they become uncomfortable and leave the group to find another group. For example, if the tolerance level is say 25%, then males are only comfortable in groups that are less than 25% female, and females are only comfortable in groups that are less than 25% male. As individuals become uncomfortable, they leave the group. They move into new groups, which cause some people in that group in the new group to become uncomfortable. And then this is kind of a chain reaction that continues until everyone's comfortable. So you can change the tolerance here. And so why don't we just change it? So if I make people more tolerant, I'm guessing that probably what's going to happen is that people won't switch groups as often. So I'm going to click setup again. And now I'm going to click go and see what happens. Now it's not going. It moved by itself. Okay. Okay. So in that case, when we increase the tolerance, then basically we have less groups, right? Am I doing that right? Am I thinking of that right? Set up. I'm going to set it up again and run it again. Oh yeah, because if the tolerance of opposite sex is very low, then it's really difficult for any groups to form. Okay, that makes sense. So if I increase it and then I click setup, yeah, then it's pretty quick to form the groups. Okay, so that's just one example, maybe not the most exciting example. And then there's another example I wanted to show you guys, which was about viruses. So I'm gonna open that now, unless anyone has any questions, or if anyone sees one in like the models library that you wanna go over together, we could do that. Okay, well just speak up if you have any like comments or anything. So I'm gonna open this other one. So I'm just gonna go back to this and go to models library, network, and then I'm gonna go to virus on a network. And I have not played with this one yet, but it just looked really cool, so I thought it might be fun. Are there any chats here? Okay, thank you, Kathleen. Okay, so I'm gonna click setup again, just like every time. Oh, I guess what we could do is read about the info on this first. So it says this model demonstrates the spread of a virus through a network. Although the model is somewhat abstract, one interpretation is that each node represents a computer, and we are modeling the progress of a computer virus or worm through the network. Oh darn, I was excited that this was gonna be a like an actual human virus, but okay. Each node may be in one of the three states: susceptible, infected, or resistant. In the academic literature, such a model is sometimes referred to as an SIR model for epidemics. Okay, so how it works: each time step or tick, each infected node, colored red, attempts to infect all of its neighbors. Susceptible neighbors, colored green, will be infected with a probability given by the virus spread chance slider. This might correspond to that probability that someone on the susceptible system actually executes the infected email attachment. Resistant nodes, colored gray, cannot be infected. This might correspond to up-to-date virus software and security patches that make a computer immune to this particular virus. Infected nodes are not immediately aware that they are infected. Only every so often do the nodes check whether they're infected by a virus. This might correspond to a regularly scheduled virus scan procedure, or simply a human noticing something fishy about how the computer is behaving. When the virus has been detected, there is a probability that the virus will be removed. That's the recovery chance slider. If a node does recover, there's some probability that it will become resistant to this virus in the future, given by the gain resistance chance slider. When a node becomes resistant, the links between it and its neighbors are darkened since they are no longer possible vectors. Okay, I feel it might be easier just to look at this than read about it. So here we have number of nodes. So, and then we have average node degree, initial outbreak size. So why don't we just run it and see what happens? So the red ones are the infected ones, if we remember. The blue is susceptible, and the gray is resistant. Okay, so I guess over time, no more nodes are able to be infected, like after it ran enough, like basically simulated itself enough. So if we wanted to change it, we could, if we wanted to give it like more nodes, we could try that. The recovery chance, like maybe if we made it lower, we could see what happens. And then if we maybe increase the virus spread chance, we can click setup again, and then we could see what happens this time. Oh, it looks like it's moving really fast. Yeah, so you kind of get the idea how like once you make a model, it's really easy to kind of change a lot of the different elements of the model and then just easily run it again and then compare the different cases. So I don't know if this would, I'm hoping that maybe some of you might want to use this maybe in your own research. One cool thing I saw was when the COVID-19 was starting like last year, I saw like on a bunch of the New York Times articles, they actually made like little Netlogo models, which I thought was really funny. It's like, oh, that looks familiar. So yeah, that's most of the stuff that I have for you guys right now. So like I said earlier, if you wanted to learn more, it's really accessible. You can go to their website, and then here they have, I think, even a bigger models library on the website. And they have it actually, the user manual is like 400 pages, and it's really thorough and explains like all the different coding stuff. And on here, if you click web, then you can get, it has information about all the different extensions and extra features like the 3D modeling and stuff that I was talking about. So yeah, that's about it right now. So here's my email address, and does anyone have any like additional questions, or if anyone wants, we can go over more different models if you guys want as well.
Thanks, Sarah. This was awesome. This makes me so happy just because I'm a visual person and I love watching the things move around. So this just made my day. I had a question for you though. Like I'm thinking about like if you're starting from scratch, like if you're building your own model, what's the process like for that? Like, did you have a specific sort of workflow that you went through, or can you talk a little bit more about like staring down the blank thing and how do you even get started on that?
Wait, staring down the what?
So like if you're like starting your new model, like I'm imagining like looking at the blank interface and going, okay, now what? Like how do you get started on making your own?
Well, that was actually kind of the, I'm gonna open ours again because I can kind of talk about it that way. That was actually really tricky. Like, I think my partner on this project and I, we spent like a few weeks just kind of reading about like through that user manual and stuff. And then I got kind of frustrated and I was like, oh, I don't really, like, it seems really simple, and it is simple, I feel like, but there's just so much different variation stuff that you can add. It just does kind of feel like overwhelming sometimes. So we tried to start like really, really simple. And what we did was we learned how to upload the GIS stuff in. And then, okay, well, at least now there's something that we can look at, like basically the basis, like the roads that we want people to be basically constrained to and moving around. So we had that in. And then from there, we added like one class of agents. And then we added like another class of agents. Like it didn't have all this stuff at the beginning. It literally just had like probably like 3 different things. And then we added like, oh, let's see like a plot of the survival of the people and everything. And then all this social science stuff is like what we added in like the last few months basically. And then let me click setup. And so yeah, I guess like basically just starting very small, and then it's really easy to make it more complicated like once you just have something running and it doesn't. So one of the things too, like we liked using the interface to see like stuff moving around, but if you don't want to look at that too, you don't have to, like they said in that tutorial. But we kind of found it to be useful to kind of visualize like what was happening and stuff. So yeah, I guess basically what we did was kind of just try to do like a little bit of a chunk at a time. And there was another guy who I had talked to who made a Netlogo model, and he was working on flooding in Colombia, and I talked to him before I started doing Netlogo, and he kind of told me the same thing, like just kind of do it like a little piece at a time, and you can just keep making it more complex if you want. So like you can also like make, for example, like the fire spread, like I said, it's not totally realistic of that exact fire, the campfire, but if we want, we can go in and try to like model it in a more realistic way and stuff like that. But we're not doing that right now. Does that kind of answer the question? Sorry, I feel like I rambled.
No, it totally does. I was thinking like trying to do everything, like put in all this complexity at once. I feel like I would have a high chance of things breaking and not working, but building up makes a lot of sense on this. And I can imagine it's probably similar to like when you're coding in R and you just have to start simple and then building up bigger and bigger things. Thanks.
Yeah.
I have a question. Hi. I'm Paulo. I have been doing agent-based models for like a little bit. And one of the things that I have been finding like challenging is that since you have like a lot of flexibility, like, and you can add like a lot of complexity, like models can get, I don't know, like very intense sometimes and like a little bit out of hand. So I don't know if you have like any recommendations on maybe some books or like UC Davis classes or something that can help you a little bit more into, for example, all the part of sensitivity analysis or how to do like a good model, because I don't know, in my experience, I have been doing something similar, like reading the manual, and sometimes I just find that, I don't know, like I ended up coding a bunch of things that actually are not useful anymore, things like that. So I don't know if you have any like advice or like experience on books or classes that can help you with that.
So that's a great question. Unfortunately, I didn't take any classes that taught this. I kind of started this part of my dissertation research, and I kind of started it once I basically was done with taking classes. I had finished like taking classes really early, but I didn't. There's this book. It's like this. Let me turn up my. It's called. I don't know why it's not showing.
Do you want to read the title to us? I'll type it in the
Yeah.
chat box.
It's agent-based modeling and geographical information systems. And I feel like that book was, oh yeah, and I forgot to mention, that's also how we like started creating our model, was like by kind of following this book. And they also have like a website, and they have a lot of great information on there. But yeah, like, yeah, I totally know what you mean. I get the same feelings. And I was like, oh, like we added this. And then like when I actually look at the results, I don't really see like it changed anything. And I'm like, well, was that really, like, did we even really need to add that? And yeah, I don't really have a great answer for that. But I guess if you can try to maybe read more about agent-based modeling. Sorry, someone is like cutting the grass over there right now. If I would maybe like try to look in this book and maybe see if they have some like solutions to that kind of problem. But yeah, it does kind of feel like you could just kind of keep making it like really complex. And yeah, I don't actually know, honestly.
Thank you. I will have a look into the book. That's helpful.
Yeah, I'm looking on the UC Davis webpage just to see if I can find something. I did my PhD at Davis too, and I didn't take any modeling classes. I took a good one at University of Michigan, but it was sort of an intro situation. But I feel like we have them. I'll keep looking, and if I see something, I'll let you know. Does anybody else have any experience with classes that they've seen or heard of? All right. I'm going to interpret silence as nobody knows. We will work on that. You can also email the geospatial list. Might be a good place to ask, because spatial people will take classes in a lot of different things. So I'd encourage you to ask there too and see if anybody else in the community has an idea.
I feel like some social science classes must have some stuff, some material on this. I wish I could have taken like a class that covered this kind of material. But yeah, sorry I can't be more help to you regarding that.
That's fine. Thank you. The book seems like a great place to start, because yeah, I have been looking for classes, but haven't had like too much success. And I mean, like, I've taken some modeling classes that cover like very briefly, but I feel like usually the way that they put it is like, oh yeah, you can do whatever you want. So I don't know, like with SIR models or kind of model, usually there is already like a whole methodology around them and like guidelines to how to use them. And I feel like, at least in my experience for agent-based models, I have been kind of struggling to find like something structure of like, this is kind of what, like, because there is a lot of models and example, like this is what it looks like. But I feel like when I have been doing them, it's like, oh, I don't know if this makes sense. And yeah, it can get complex.
It looks like Greg Pasternak might have a modeling class in, I think he's in LAWR. So that might be something to check out. And I'm also seeing on my search, looks like there might be some classes in transportation too about modeling. I'm guessing more on a road network kind of situation, but those might be some things to look at and see if any of those work. Oh, there's also, I'm finding the methods models in GIS list for geography that might be.
Oh, Mackenzie just wrote in the chat, we went over Netlogo in the computational social science class, but it was super basic and didn't bring in the spatial component.
That's good to know. Yeah, a lot of times at Davis, there's a lot of digging that needs to be done to find a class. And then sometimes you need to make your own and do like a grad experimental, like 298 kind of situation. And I think if it was of interest, like Data Lab could probably provide physical space when we're back in person. If you need a place to meet, that might be an option too. So, if anyone's interested in doing that, I can help facilitate that.
That would sound really great. Really, like that sounds very useful.
Yeah.
This book, I do feel like it was really easy to follow, and it does give a lot of great stuff, and it has the stuff online. So I kind of almost treated this like a class, but like to actually be able to talk to other people like working on the same stuff would have been like really helpful.
Yeah. So true. Are there any other questions? I can also, if we're to the point where we're ready to turn off the recording, if people just want to stick around and chat, we can do that too. How's everybody feeling?
I'll stop sharing.
Okay, so I'll go ahead and I'll turn off the recording and just say thank you, Sarah, and we will continue the discussion off the recording.
Thank you, everyone. Thanks.